Hi, welcome to the lecture on Neurocranium, specifically the frontal, ethmoid and parietal bones. Since this is the first lecture on cranial bones, we need to explain how to divide all this, so we don't get lost. Let's start with the simplest division into the neurocranium. That is the bones that surround the central nervous system, and viscerocranium, smaller bones located in the front. Let's start with the neurocranium. First, let's list the bones that make up this group. These are the frontal bone, paired parietal bones, occipital bone, the sphenoid bone here, paired temporal bones here and here, and the ethmoid bone, which we will not see in this picture, but it is located here. As always, let's discuss each bone separately, and we'll start with the frontal bone. We're looking at its outer surface. When moving your fingers over your own cranium, you can sense certain protuberances or bumps. These are the frontal eminences here. In Latin, we can say tuber frontale. Another one is the superciliary arch here, arcus superciliaris. These ridges connect in the middle, creating the glabella. The supraorbital margin is located just below these ridges. The supraorbital notch, or foramen, is located in the medial part of this margin, for example here, and the frontal notch is even more medial than that. It could be here. The first structure is the passage point for the supraorbital nerve and vessels. The second one houses the supratrochlear nerve and vessels. The supraorbital margin continues laterally as the zygomatic process, here and here, it forming a connection with the zygomatic bone. Let's look at the frontal bone from the inside. In this case, we are looking at the cranial vault, or calvaria. Frontal bone ends more or less in the location indicated with a dashed line here. This line correlates with the coronal suture, sutura coronalis. This is the connection of the frontal bone with two parietal bones. It is also worth adding that the frontal plane runs through the coronal suture. We can see a longitudinal groove running through the cranial vault. It is called a groove for superior sagittal sinus. This is where we have to stop and explain what the sinuses are. In anatomy, this term has two meanings. On one hand, these are pneumatic spaces within the skull. That means that they are filled with air. In such case, we are talking about the paranasal sinuses, which one knows from TV clips advertising sinusitis medications. The second meaning is related to the arrangement of the cranial venous sinuses, and these are simply large veins into which blood drains from the brain, and the superior sagittal sinus is one of them. In this photo, we can also see that this groove continues into the frontal crest here. While we are still at the cranial vault, we can look at these hollows called granular foveolae, for example here. These are places created by the arachnoid granulations, simply the bulging of arachnoid matter. Filtration of cerebrospinal fluid from subarachnoid space into the blood takes place here. Another thing that draws our attention are the arterial grooves, sulci arteriosi, spaces hollowed out by meningeal arteries, mainly the middle meningeal artery, the remnant of which we see in these places. This time let's look at the cranium from above. In this case we can see cranial cavity in transverse plane. The frontal bone is located approximately here, so it articulates with the sphenoid posteriorly, specifically through the lesser wings. In this view we can notice the continuity of the frontal crest. It ends with a small opening which we can call foramen caecum here. It means a blind opening, and as the name indicates, it does not lead to another area. It's worth noting here that the structure immediately adjoining doesn't belong to the frontal bone, but forms a part of ethmoid, which we will discuss later. Walls of the frontal bone contain specific space called frontal sinus, and this sinus is the pneumatic or air-filled space. Frontal sinus communicates with the nasal cavity. To round off the frontal bone theme, we need to mention its orbital part, which forms the orbit. Its lateral part houses space for the lacrimal gland, and we call it the lacrimal gland fossa. Another hollow can be found medially. It's called the trochlear fossa. Trochlea is a structure through which the eye muscle tendon passes. Since we have started the topic, let's say a few words about the ethmoid bone. I included an extract from the cranial cavity picture. We were discussing foramen caecum, and the structure behind it is crista galli here. The skull visible in this photo is already slightly damaged, but we can still see the remnants of cribriform plate, ramina cribrosa. It's well visible here. As the name suggests, the structure is richly perforated. Olfactory bulb lies on the cribriform plate and sends its olfactory fibers down into the nasal cavity, so it nicely explains the name of the ethmoid bone. Ethmoid comes from the Greek meaning a sieve. The anterior view of ethmoid will show us some more parts. In the middle we can see the perpendicular plate aligning with sagittal plane, and the entire bone mass to the side is the ethmoidal labyrinth. Ethmoidal cell, cellulae ethmoidales, are located in the center of ethmoidal labyrinth and we can divide them into anterior and posterior ethmoidal cells. This time the word cell has a different meaning, as it describes air-filled space, very similar to a sinus, only much smaller. Most laterally we will find the orbital plate here, also called paper plate. It limits the orbit medially. Looking back at the labyrinth, we can notice that it limits the nasal cavity superiorly. And this is why this structure contains the superior and middle nasal concha. Here is superior and middle here. The part sticking out of the side is uncinate process uncinatus, a spot connecting with inferior nasal concha. There is nothing remarkable about the parietal bone. We need to remember that it is a paired bone. On its surface we can see the parietal eminence. Acknowledging a simple structure of this bone, we'll focus on its ridges, which form sutures. We already talked about its articulation with the frontal bone and the formation of coronal suture. At the medial border, parietal bone articulates with its sister bone, forming the sagittal suture. The entire sagittal plane runs through this articulation. Many different cross-sections are shown in the sagittal plane. At the posterior border, the parietal bone articulates with occipital bone via the lambdoid suture. The name might cause you to ponder. In Polish it seems to be derived from the word used to name an angle created by two wooden walls of a building. You might want to analyze the Latin origin of this term, and I will leave this to you. Feel free to share your thoughts in the comments. The fourth ridge of parietal bone is formed by the squamous suture, as it articulates here with the squama of the temporal bone, thus forming this suture. Thank you for your attention. See you soon. School of Anatomy, Maciej Haberka.